Hello, and welcome to Foundations for Algebra, Unit 4B, Lesson 3. Today's objective is scholars will distinguish between linear and exponential or nonlinear functions. So first of all, we're talking about linear or exponential. Linear functions have a constant rate of change. That's what makes them a line. When you graph them, they're a line. When we're talking about exponential functions, they have a constant ratio of change, not a constant rate. And if you see a graph of them, the graph will be a curve, not a line. So, how can I tell the difference on a graph? So, linear functions, it's a line. So, here I see a line, here I see a line. Lines are caused by the fact that they have a constant rate of change. That's what makes it a line. So if anyone ever says, why is something a line? It has a constant rate of change. Why is it not a line? It does not have a constant rate of change. But you'll notice on these exponential functions, it's not a line, it's a curve. You see that on both of these. These are exponential functions. They both show exponential growth and they both show curves. So an exponential function, when you look at the graph, will look like a curve. So next, let's talk about how we can tell on a table. So let's start with this first table right here. I'll notice that the x side is increasing by 2 each time. The y side increases by 3 each time. So there's 3 here, 3 here, 2 here, 2 here. Change in y over change in x. 3 over 2. This is a line. But here, I see I go from 0 to 1 to 2, so this is steady. I go from 3 to 9 to 27. So I increase by 6. And then I increase by 18. So this one, you'll notice I'm multiplying. This is a ratio of 3. 3 times 3 is 9. 9 times 3 is 27. So our ratio is 3. So this one is exponential. It's not linear. Let's come here. Again, my x's are going up by the same amount each time. My y is increasing by 10. Oops. So that's the wrong side. By 10. And then here I'm increasing by 20. So this one is definitely not linear, because here I'm increasing by 1 and 1. This one I am multiplying by 2. 10 times 2 is 20. 20 times 2 is 40. So this one, the ratio of change is 2. So it is exponential. Finally, let's look at this last one. Here I'm increasing by 5. And then I'm increasing by 15. What I need to watch, let me move this over a little bit. Okay, what I need to watch is, here I'm increasing by 5. Here I'm increasing by 15. 5 over 5 equals 15 over 15. So this one is linear. This one is linear. Okay, so now, what if I'm talking about an equation? Anything in the format y equals mx plus b. So if I have y equals 5x, if I have y equals 7, anything in ax plus by equals c. Basically, if we have an x and we have a y, and there's no exponents, it is linear. Those are linear functions. Well, exponential functions, remember, we have that x up there in our exponent. We have it here also, x in the exponent. We know that these are exponential, nonlinear functions. Finally, what about when I'm talking about a situation? So, linear functions, anything that increases or decreases by the same amount, a constant rate. In this case, a tree is 5 feet tall and grows 1 foot per year. Every year it grows 1 foot. So that is a constant rate of change. We have a constant rate, so it is linear. Exponential functions increase or decrease by a common ratio. A bank account increases by 5%. We're talking about percent, then that is definitely non-linear. That is exponential. That's exponential because it's not 5%. It's going to be different each year. Okay, so go ahead and work on these on your own, and I'll see you in class.